Alright, so tonight we're going to be looking at 6.2, which is all about properties of parallelograms. So first of all, we need to know exactly what a parallelogram is. A parallelogram is a quadrilateral that tells us it has 4 sides. With opposite sides congruent. Or not congruent, I'm sorry, parallel. So it's a quadrilateral with opposite sides parallel. That is a parallelogram. Okay, so here we have parallelogram A, B, C, D. And if we were going to write that, the way that we would do that is a little parallelogram symbol, then A, B, C, D. Okay, so parallelogram actually has a nice little symbol for it. And we know that this is a parallelogram because AB is and BC is parallel to AD. So because both pairs of opposite sides are parallel, we know that this is a parallelogram by the definition of parallelogram. So that is just what it means to be a parallelogram. The next thing we're going to look at are some of the properties, some of the theorems that a parallelogram has. And the first one of these is that opposite sides are congruent. So in a parallelogram, opposite sides are congruent. So for instance here, AB would be congruent to CD, and AD would be congruent to BC. So we can write a little congruent mark to show that that is true. So opposite sides, both pairs, that's really, really important, are congruent. All right, the next thing we're going to look at is if these are parallel lines, we know that these two angles are same side interior. And we know that when lines are parallel, same side interior angles are supplementary. So all pairs of consecutive sides, that means sides that are beside each other, or consecutive angles, are supplementary. So all pairs of consecutive angles are supplementary. All right, so for instance, A and B here are going to add to 180. A and D are going to add to 180. C and D are going to add to 180. And B and C are going to add to 180. Okay, there's lots of pairs. So the measure of A plus the measure of B is 180. Also, the measure of angle A plus the measure of angle D is 180. Which kind of leads us into the next little theorem that uses parallelograms. If all consecutive angles are supplementary. So for instance, A is supplementary to D, but C is also supplementary to D. That means that A and C have to be the same measure. They have to be congruent. So not only are all pairs of consecutive angles supplementary, both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. So here, A is congruent to C, and angle B is congruent to angle D. All right, so there is one more theorem left to look at with parallelograms. And to see that last theorem, we need to draw the diagonals of this shape. Let me redo that. So remember, a diagonal goes from a vertex to a vertex. So there are 2 diagonals in this parallelogram. Here they are. So looking at those diagonals, if we were to measure each one of those, it actually turns out that the diagonals bisect each other in a parallelogram. So the diagonals bisect each other. Notice they are not congruent, they just bisect. And remember, to bisect means it cuts it in half. So for instance, if I labeled this middle point E, AE is congruent to EC, BE is congruent to ED. The diagonals bisect one another. So AE is congruent to EC, and then BE is congruent to ED. So diagonals bisect one another. So those are all the properties for parallelograms. I told you this one wasn't going to be too long. Now we're going to look at some examples involving using those properties. So let's start with 2a. Let's solve for x first, see if we can figure out how to do that. So here x stands for this angle, and it also is used in this angle. So looking at those two angles, if this is a parallelogram, we know that those two angles are same side interior. So they are not congruent to one another, they are supplementary. So 4x plus 2x minus 6 has to be 180. So don't set those equal to one another. Remember, you can always use the guide of this one's obtuse, this one's acute, so they're not going to be equal. The only other choice is that they are supplementary. They add to 180. So here's 6x equals 186. So x here equals 31. So now we need to solve for y. So if we're going to solve for y here, we have a y representing that side. We also have a y in this side. So we know in a parallelogram that opposite sides are congruent to one another. So therefore 5y equals y plus 8. So 4y equals 8. So y here has to be 2. So those are using those properties of parallelograms to solve for missing variables. Let's look at the last one, 2b. So if we're looking at 2b, we have that this length is 3z minus 4, and that this one is z plus 5. Well, those both represent pieces of the diagonals, and our very last property from the slide before was that diagonals bisect each other. So those two lengths there have to be congruent. So therefore 3z minus 4 has to equal z plus 5. So 2z equals 9. So z is 9 over 2, or you can write that as a decimal, 4.5. So that is the value of that variable. So those are applying the properties of those parallelograms. It's not too bad. What we'll do tomorrow is we'll look at a few proofs involving those parallelograms. Why do we know, for instance, that opposite sides are congruent? Why do we know that diagonals bisect each other? Things like that. So we'll look at those. There's one more type of problem before in this video, though, that I want to go over, and it's this type right here. And what it says determine the coordinates of the intersection of the diagonals of parallelogram FGHJ with the vertices blah, blah, blah. Okay, so it gives you all the vertices there. And so I went ahead and graphed the parallelogram. You don't have to do that. So if I want to find the intersection of the two diagonals, so my diagonals here are FH, and then my other diagonal is GJ. Those are my two diagonals there. So if I want to find the intersection, I want to find where they meet each other. Well, here, our last property was that those diagonals bisect one another. So that means basically that they intersect at the midpoint of each diagonal. Since that's being bisected, I know that that point there is the midpoint. So if I can find the midpoint of the diagonals, then I know where that point of intersection is. So we have a formula for midpoint. That formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So if I can find the midpoint of one of those diagonals, I know where that point of intersection is. So let's find the midpoint of FH. Okay, so I want to find the midpoint of that. So I need to plug in what I know. I have here's point F, here's point H. So I have x1, which is negative 2, plus x2, which is 2, over 2, comma 4 plus negative 3 over 2. So if we solve that, negative 2 plus 2 is 0 over 2, comma 4 plus negative 3 is 1 over 2. So that's just going to be 0 and 1/2 are 0.5. So that would be the intersection of those two diagonals. And if you want it, you could check the midpoint of GJ as well, and you should get 0.5 for that one too. So the last thing I'm going to ask you to do tonight is to write your own problem using one property and x as a variable. And I will be checking for this tomorrow when I go around the room and check notes to make sure that each person has their own individual problem and no two are alike. So here I use the fact that opposite angles are congruent to kind of make a little problem, and I also solved it. You could use the fact that diagonals bisect, or that consecutive angles are supplementary. Okay, any of those 5 properties to help you solve that problem. All right, see you tomorrow.